Right. Okay. So let's just assume that everyone's made it across safely. So welcome back to the Grant Institute. This is our main lecture theatre. It will not look like this when you arrive. We're having it kind of totally refurbished over the summer. So it will have a nicer carpet, perhaps, and some more comfortable chairs, and kind of like places to plug your laptops in, all that kind of stuff while you're in lectures, which is kind of the same at all universities, certainly all of our lecture theatres is being constantly updated and whatnot. You might have noticed that I was kind of setting our lecture capture system to record, so that's kind of a thing that we do for almost all of our courses. So not just so you don't have to turn up, but they're actually used quite a lot by students for revision, to make sure you understand the subject, so you can ask questions to clear your understanding before the next lecture. Sometimes we use the lecture capture so get students to watch lectures before the lecture, so you turn up and then bring questions with you. So I'll try and make sure that this recording is available to you. I'll post a link to either our lecture capture software or post it on YouTube as soon as I can after this. So pay attention, but there will be an opportunity for you to pay attention in the comfort of your own home. Saying that, I'm also going away next week teaching on a field trip to the Lake District, so I might not be so speedy with that uploading, so bear with me. Anyway, so the first presentation that we're going to have will be about why you might want to study earth sciences in Edinburgh. Unfortunately, we don't have a representative from the Students' Union who usually comes along and give a talk because all of our representatives are currently on field trips in either Cyprus or Jamaica or somewhere at the moment, so sucks to be them, I guess. And then I think that there will be a presentation by someone from the accommodation office, but if they don't turn up, I will give that presentation as well, which I've done before, so I know all about that and can answer many questions that you have. Not necessarily all questions, but anyway. Right, so Earth Sciences Edinburgh. Hopefully, you all know what Earth Sciences is as a broad subject grouping and kind of want to do it. So I'm not going to dwell too long on this slide, but basically we want to understand this thing that we live on, not just limited to the thing we live on. This, for instance, is Venus up the top here. But we're interested in planetary evolution, how stuff changes on the surface of that planet, the process involved in that, and we use physical sciences to do that. Okay, so we use maths, physics, chemistry, biology as tools to look at the Earth. So that can be either remote sensing, using, for instance, satellite data here to look at the productivity in the ocean, using just the colour of the ocean. Or it could be using other satellites, such as this is the GRACE satellite data, using gravity to look at the structure and Earth surface processes and Earth processes going on in the deep Earth. Or it might be using physics like seismic waves, looking into the interior of the Earth. It's a hugely broad kind of subject area across a whole bunch of different spatial scales and also temporal scales. So looking at processes that are going on the kind of a second to billions of years. Okay, so it's very broad and interesting and really relevant. So everything in this room, anything in any room, in fact, okay, was either grown on a tree, okay, or was dug out of the ground by geologists, okay, providing the resource for those plastics or metals or whatnot. Even the trees, okay, need nutrients to grow. Those nutrients are often mined, or if they're not mined, understanding of those nutrient cycles. So a degree program such as environmental geoscience is critical for providing us with all of the resources we need for the fantastic society in which we live, which is fun. Okay, so I'm going to go over quickly some of the reasons why you might be thinking about coming to Edinburgh and whether they're good reasons or bad reasons. And then we're going to talk a bit more detail about the courses and stuff actually that we do within the School of Geosciences. So I think the first reason why people think of coming to any particular university is the reputation of the university. I think Edinburgh is a very good university, founded in 15 something or other, very old, very prestigious. This is a rubbish reason to choose to come to university. Okay, so the reputation of the university as a whole is kind of important in that when you have your degree at the end and you're telling someone in Guinea-Bissau or in South America about, I want a job with your company. Oh, Edinburgh University, I've heard of that, right? So, but that's really the only level that it matters, okay? really important stuff is, are you going to enjoy studying here? Okay, and that's really the fundamental question. Because if you're not enjoying what you're doing, enjoying your time staying here, then you're not going to perform very well academically. So the city of Edinburgh is actually a really good reason to come and stay here, because you are, sorry, I say stay here. It's a very Scottish thing to say. I'm becoming more Scottish. Very important, you're going to live here, so stay means live in Scottish. So you're going to live in this city for 3, 4, or 5 years, and it's a really good place to live, especially as a student. There's always fun stuff going on. So as an example, last night I went to an event which can only be described as free beer, which was really good. So at a kind of a social enterprise down in the West End, there was some free beer, so I had that. And tonight I'm going to a ceilidh, which is kind of a dancing thing, which if you come here you'll learn. If you don't know what a ceilidh is, you will learn. There's always something fun going on. It's a really big multicultural city, lots of exciting things going on. The city is in the country of Scotland, which is a fantastic place to live as just a country, but also particularly for earth scientists, it's a fantastically fascinating place to live because it's so geologically diverse. There's lots of really interesting geological things that have happened in Scotland that you can go and observe on kind of fun trips, but also as part of the courses. So this is the island of Skye with the along the Trotternish Peninsula with these kind of photogenic lavas, which are pretty nice. Another reason why you might want to decide to come to Edinburgh is the staff that will be teaching you. So this is a selection of the staff from the School of Geosciences, the group of people that are conceivably could be teaching you on an earth sciences degree. Okay, so this doesn't include a lot of the geography-based staff or the ecological and environmental sciences staff. And the point I'm trying to make here is that there's a lot of people here. Okay, it's the biggest collection of geoscientists in the country, one of the largest in the world, and this is important for our research reputation and all that kind of stuff, which kind of is important, but it's really important for your teaching because it means that you have a wide range of expertise. So when you get on into the 3rd and 4th year or 5th year where you want to do a research dissertation or some optional courses, you're not limited really to the areas where 1 or 2 staff have some expertise at world-leading level. We've got a huge range of people. We've got people studying glaciers, studying the core of the Earth, studying kind of environmental pollution, studying plate tectonics, studying sedimentary systems, geomorphology. I mean, the list goes on and on and on. Okay, so literally from the core of the Earth to the clouds of the atmosphere, we have people studying. So it's a pretty exciting place to be because there's always something that will kind of like interest you. We have most kind of geology departments might have a lecture series a week where they bring in an external speaker and talk about the kind of the cutting edge science. Because we're so big, we have 3 of those a week. So there's always something going. So we have one in Earth surface processes, physical geography, which includes things like glaciology and fluvial process. We have one in global change, which talks about climate modeling and climate change and the atmosphere. We have one in Earth and planetary sciences, which is kind of more geological type talks. Huge range of things going on, huge scope of intellectual activity because we're really big, and that's really important. But perhaps the most relevant thing for you guys are the courses. Okay, so I'm going to spend quite a lot of time now going through some of the details of the structure of our courses and some examples of options and some of our means of assessment. But before I do that, I should just point out that actually students are really important too. I mean, obviously, you think you're important, we think you're important too. And it's not just because, you know, there's a great bunch of people you have some fun with on field trips and pretend to be Romans and all that kind of stuff. I guess Greeks because it's on Cyprus. But it's because we're a big university, because we're kind of a reasonably large intake every year, about 100 earth science students, smaller groups for each kind of individual course. But these are the people that you'll be learning with. Okay, and because Edinburgh is kind of a good university, it attracts good students, it's attracted you, and at least you think you're good. And we think you're good as well. So, I mean, it is competitive to get an offer to come here, so congratulations on those offers. And you'll be learning with a group of well-motivated, highly intelligent students. And actually, most of the learning you do at university is not really from people like me, standing at the front, telling you stuff, or say, go read that paper, or do this practical exercise, or eat those sweets. You learn from each other. Okay? And we recognise that. We structure a lot of our learning around groups, whether that be working in the field with like in a small group or a large group of students going around making observations, talking to each other, but also in some of our assessments where we enforce group working. Okay? So that is not only an important transferable skill, but it actually helps you learn talking to each other. And talking to a bunch of well-motivated, intelligent students does help. So the reason you should come is you, which is a bit counter-circular argument, but you're good. Again. So just briefly, kind of, I have this slide to kind of explain where our earth science degrees sit within this thing called the School of Geosciences. So universities have schools or departments because they need to have buildings for people to sit in and do research and teaching. It's slightly artificial, right? So some of the teaching that you will have will be from other schools, from other departments. Some of the research we do is across schools and departments in other universities. So it's kind of artificial a little bit that we have this School of Geosciences, but it does bring together kind of the earth sciences with subjects like you might think of geography you might have at school. A bit of our geography department kind of intellectually sits outside what you might traditionally think of as physical geography. So we have people doing cultural and human geography, which is kind of a really good resource to have because it makes quite a lot of the science that we do able to be applied to the real world, to actual societal problems. We have a group of ecologists that sit within the School of Geosciences, and there's a little bit of overlap there with some of our teaching, particularly with our environmental geosciences degree. But if you come and do geology, you won't just be doing geology. You'll be doing some geophysics, you'll be doing some environmental geosciences. I mean, it's quite hard. In fact, it's impossible to draw a two-dimensional representation of the amount of overlap between the subject areas within the school. And actually, for the most part, what you start out thinking you're going to do as a degree doesn't really matter because our degrees are quite flexible, allowing you to switch and choose and take optional courses in what you're interested in. So if you take geology and you actually think, oh, I really want to do some ecology, you can make that happen. Or you want to do some geophysics as part of your degree or some geography, that can be fitted in. And we'll talk about how that happens. So we're going to go through some of our degrees in a little bit more detail now. I'm going to go through and group together the geology and physical geography and environmental geoscience degrees because they start out very similarly. And we're going to treat the geophysics degrees a little bit different because they are a little bit different. But just to point out that we do also have other degrees going on. So we have geography degrees, physical and human geography, and also with management and business and that kind of stuff. So we do those kind of activities, those aspects of those degrees do kind of make an appearance in some of our degrees later on. So just looking at the structure of the first 2 years. So we treat the first 2 years as what we would call pre-honours. So none of this counts for your marks, for your overall classification. It just means you've got to pass them, and then your final degree classification is based on your third and fourth year. So in the first year, the geology, so we have acronyms for everything, which makes life convenient for me, terrible for you. So geology, EG, which is environmental geoscience, and GPG, which is geology and physical geography. And then all of our courses have acronyms as well, which is very confusing. But to a certain extent, it doesn't really matter what the acronyms are. You'll be doing some courses in the first year, which you have to do in terms of they are the core courses to give you the fundamental grounding in the earth sciences. So there'll be a course on earth dynamics, which is a really straightforward introduction effectively to geology. So how rocks form, where they form, why we get plate tectonics happening, what's the structure of the interior of the Earth, why we might get volcanoes in one type of subduction zone, why we might not get them in another. So that's a course that incorporates a little bit of field work. We go out into the borders near Edinburgh to basically start you off on your kind of like field education. We have a course on Introduction to the Geological Record. So if you had a look at some of the samples on the back of the lab today, that's the kind of thing that some of this course will be doing. It's basically how you start to make rigorous scientific observations, okay, quantifiably from hand specimens of rocks, from looking down the microscope at rocks, but also starting to think about how we would observe these in the field, outside, how we bring together the spatial kind of arrangement of those rocks, to start about how we make geological maps, to understand how an area has evolved through time. So that's involved. So I'm going on the field trip for that on Monday. So we're going out to the Lake District for a week to basically to put some of the stuff that you've done in the lectures and the practicals into practice in the field. Evolution of the living Earth. So that was the first half of the practical with the suites. So that's only a small part of that course. It's really about the history of the planet, how it formed, how it became habitable for life, and how life evolved on it. It also brings in some chemistry, because that's really crucial for understanding how life evolved. I mean, how did we get oxygen? When the planet formed, there was no oxygen, couldn't have complex life. Some processes, some Earth system processes went on to allow the planets to become have a breathable atmosphere. But it's not just oxygen, it's all of the other elements critical for life that you need to understand as well. So nutrients like nitrate, phosphate, how they move through the Earth system is really important. If you don't have maths A-level or maths higher, we'll ask you to do some maths depending on which course you're doing. And then you get some options. And the options can be anything. Okay? So if you want to do kind of options within geosciences, there are courses in natural hazards or volcanology, those kind of things you can kind of take. They could be maybe geographical. You could do maybe sustainability in the environment, courses like that. Or they can be anything else. French, comparative Romanian literature, any course from the university you can take in these things here, and I'll show you some of the options later on. In fact, actually, so we have a web tool which you should all have access to. So if you go to your MyEd portal, which you should all have a password for from when you applied, if you go across the top bar there's a tab for teaching, and then one of the options is a thing called PATH, P-A-T-H. If you click on that, you can navigate through to whichever degree you're interested in, and it'll tell you what your core courses are, and it'll enable you to search for the database of all of the courses across the university which you can take, which is all of them, except medicine and veterinary science. So it's hugely broad. So it's one of the really fundamentally different things about education system in Scotland is that in the first 2 years, you have all of these options available to you to explore your intellectual interests. That if you're not sure whether you actually want to be doing geology, or you think, oh, I quite like history, or I haven't, maybe some physics might be interesting, then you can put that in, and we can make that happen. So you have a very flexible first 2 years to really allow you to develop your kind of intellectual breadth as wide as you can. In the second year, we start to specialise you down into your individual degrees a little bit more. There's one course that everyone does, which is called Geomaterials, which is effectively mineralogy. So it's understanding the physical and chemical properties of the things that the Earth is made of. So that's not just kind of the rock-forming minerals, but also kind of the minerals that form in soils, in the ocean. And how we use that kind of physics and chemistry to kind of read back what were the environments that or the conditions which those minerals formed. So how deep in the Earth did that garnet form? Does that mean that we could have diamonds in that rock? Those kind of questions. And then we split into our kind of different degrees. So a geologist might take a course in global tectonics and the rock cycle, which takes the stuff that you've done in Earth dynamics a little bit further. And we start to look at the relationships between Earth system processes like volcanoes and plate tectonics and mountain building, and the development of sedimentary basins and the physical processes of sedimentation. What is it that controls what physics controls the sediments that we get? I'll start with a course also in Introduction to Geophysics, which is basically how we use some of the things in physics, like magnetism, like gravity, like wave theory, how those are used in the geological sciences. Environmental geoscientists will take a slightly different route, and they will take a course in oceanography, which is an introduction to how the ocean works, looking at how you physically move around a fluid on a rotating sphere, but also how that physical circulation relates to the chemistry and the biological cycling of elements throughout the ocean. So it determines where and how much life the ocean can support. So similarly, a course on environmental geochemistry of the Earth's surface, which is all really about the little bit of the Earth that we live on, the thin brown crust on the outside, which has got a lot of interesting chemistry, which is important for pollutant transport, which is important for nutrient availability. So that involves another field trip to the Lake District again. but a slightly different area. And then the physical geographer, the physical geography, the GPG students similarly have the same course with the geologists, but then have an additional course in geomorphology. So this is about how you can observe the structure and shape of the landscape to tell us about what processes are going on now and what processes have gone in the past. So we may look at a landscape and say, well, actually, this is quite a nice place, safe place, or are we going to have lots of landslips here? And what do those landslips tell us about, what the hazard is, but also maybe potentially what the climate of the past has been to lead to those landslips? Is that the same risk now? So I'll just point out that at this point, if you were unsure which one of these options that you wanted to take, okay, you could in your second year choose to use some of your options here. So if you were doing geology and you're thinking, oh, I'm not so sure about that geology, I might quite like to go to Jamaica in my third year and do environmental geoscience. Just saying. You could opt to take these two courses in place of some of these options, and then you'd make that decision about which degree program you ultimately ended up onto at the end of the second year. Okay, so that's adding a little bit of flexibility. So that flexibility is true for all of these degree programs for geology, environmental geoscience, geology and physical geography. It's kind of true for geophysics as well. So although it's a lot easier to switch from geophysics to these degrees, it's very difficult to switch the other way. Okay? And we'll come on to why that is in a bit. So just some examples of some of the options that you could take. I mean, it is impossible to put all of the courses that you could do on a slide like this with the resolution of the screen we have here. I mean, even if the smallest text, they would not fit on. There's hundreds, if not thousands, of courses. But they can be in anything. So they can be things that are related to our degrees. So there's a great course in physics on astrobiology, which is like how life could exist on other planets, how it might have either evolved or been transported around the solar system, how we might use some of the remote sensing techniques we have with telescopes to detect whether a planet has life on it, what gases would we expect to see, what's the spectral signal of those. Like I said, of course, there's natural hazards, but you can also go off-piste. You can go and do politics, you could go and do anything, philosophy, geography, art, anything. Archaeology. Right, so geophysics now. So this is why it's slightly different. And it's slightly different because the first year there are no options. And there are no options because in the geophysics we need to make sure that everyone has a really solid fundamental grounding at a level of maths and physics that is some way above advanced higher or A-level. So to do that, we have our students do the core courses. These 4 courses here are the core courses that physics students have to do. So they are the same courses. So you'll do maths for physics 1, maths for physics 2, physics 1A and physics 1B. So this gives you the fundamental grounding in physics and maths. And you'll also take some courses that introduce you to the Earth, okay? Particularly how we look at it with physics. So in that respect, you can start doing this, and then it's quite easy to swap into the earth sciencey, geology or geology and physical geography courses. It's quite a lot harder to switch the other way because you won't have done these courses here. Okay, not impossible, but you might have to repeat a year to do that. But that does happen. People do that, and that's fine. So just like the other courses in geophysics, when we move into the second year, we start to specialize. So there are some core courses that you have to do, some more maths, dynamics and vector calculus, and physics of the Earth, which basically takes the introduction to geophysics a little bit more in depth, a bit more mathsy. But then you start to specialize into your chosen kind of subject. So that can be geophysics. They just do the global tectonics of the rock cycle course to add a little bit of geology to their degree, but then they get some more options. Geophysics and meteorology, which takes some looking at the meteorology, atmosphere, and the environment, which is basically how we just physically describe how the atmosphere moves around. So there's a little bit of maths in that, but not a huge amount. And then we have Met, Weather, and Climate, which is a course which is all about how we model kind of the current climate, and past climates, and future climates, and the various techniques we use to do that. So that follows quite a lot of the research that our our school does here, is very strong in the area of basically climate prediction and climate forecasting. The geophysics and geology degree then brings in a little bit more of the geology core courses from that course. So looking at the overall structure now, we've kind of gone through this first and second year, this pre-honours, so you get some core courses, you get a lot of options. I should point out that some of you may have applied for direct entry into the second year. In that case, you effectively don't get those optional courses, you just do the core courses for your degree and condense the whole thing down into 1 year. If you've not applied for that, but think that it's something you might want to do, that is an option that may still be open to you depending on what kind of A-levels or hires or advanced hires you have, and the grades and or subjects that you have with those. And it would be worth having an individual one-on-one discussion about that, either with the person that you're going to meet later on or with your personal tutor before you kind of turn up in the first week. So that may be still available to you. So the third year, we kind of, for most of our degrees, we take away some of those options. So with all of our degrees, with the exception of geology, you get one option whether you do petroleum systems or hydrogeology, or the GPG course, the physical geography, you get a little bit more in the ways of how many geography options versus how many geology options you take. But we reduce the number of options available for most of the degrees in the third year so that we can make sure that you've got enough knowledge and skills, okay, that you will then be able to do the high-level courses. So we restrict you down a little bit in the third year. Sometimes we restrict you down quite a lot, so that we can make sure that when you come to your fourth year, you can actually make sure that we can have you do a really good dissertation that's not kind of a bit woolly and kind of blurry because you've not done the right preparation for it in the third year. So in the fourth year, you have this dissertation, which we've prepared you for in the third year, and you then have some core courses, which bring together the courses that you've done in the third, and to a certain extent the pre-honours as well, so you're basically now at the cutting edge of the science. So those are usually courses which are based around discussion rather than lecturing. And then we have some optional courses which you can do, which are, once again, to make use of this really broad intellectual capacity that the school has, that we have a wide range of options available to you. And you can check those out on Path. I'll show you some examples in a bit. So it's the marks for the third and fourth year which go forward and count for your overall degree classification. The fifth year is an optional available to the geology and physical geography, and the geophysics degrees. It's not available to the environmental geoscientists. But you basically take that dissertation and you do another dissertation, basically more in-depth, takes more of your time. It has a lot more master's level courses in it, so it's shared with some of our master's programs. We have quite a broad selection of master's programs available to us across the school in other areas, so those kind of get incorporated into that fifth year. So that's really, if you think that maybe pursuing a career in science is something you might want to do, this is quite a useful option to take up. It's basically a kind of try before you buy in terms of doing a PhD. If you think you want to do a PhD but don't want to spend 3 years finding out you want to do a PhD or not, doing it for a year is basically what those courses are all about. So what I'm going to do now is just go through an example of one of the courses that actually I was involved in developing to give you a kind of a flavour of what courses at university are all about. So this is a third year course. It's new for this year, and it's broadly in the field of geochemistry, so using kind of chemical techniques to understand something about the Earth. Now, in the past, maybe more than 5 or 10 years ago, most courses in university were kind of lecture-based, so there would be a lecturer, they would lecture, then students would go away and remember that somehow, and they would write it in an exam, and then they would be disappointed with their marks. But we really are moving, and all universities are moving away from this because we realise that it doesn't work very well. And the reason we know it doesn't work very well because it's through results, but also through quite a lot of student feedback, is that they actually like quite a lot of these alternative methods that we're using. So this course brings in not only some of the theory that's been taught in universities for a long time. I guess it's the actual science is updated, but the idea of teaching theory is not. So we do have some components of the course which basically is lecture-based, where the lecture is recorded and we do make students watch videos before lectures, and then the lecture becomes more of a discussion workshop, but it's similar kind of format. So students learn some theory. But we also take the opportunity in this course to do some data processing and some programming and introducing effectively some useful transferable skills. And rather than do that in a kind of an abstract way, we've incorporated the programming exercises to include the data that we're using in the theory. So it kind of makes more sense that way to students. It's kind of more relatable and also is more useful. So this brings an alternative method of assessment. So rather than just having an exam where you say, I learned this programming, we actually get the students we give them a data set and say, can you present this data set for us? And show us the program that you've used to process that data, and then there's points for prizes at the end of that. But the really nice thing about this course is we actually then, because we're a research-intensive university, we have all of this research analytical kit kind of lying around, so we use it. So we divide the students up into groups, which forces them to work in a group environment, to organise their time, and to work as a team, that kind of stuff, which is an important skill that students need to have nowadays. And we give them some samples. So the geologists were given samples from a volcano in Iceland. The fifth year, the year before, had samples. It's a volcano that hasn't really had any research on it before. And we gave them those samples. The environmental geoscience students got some samples from a loch in Scotland, which we used as a field trip in the fourth year. And we kind of let them loose on the instruments. So we used the electron microscope, we used X-ray diffraction, X-ray fluorescence, we used optical emission spectroscopy to look at the chemistry of chemical leachates from some of the sediments, huge range of techniques. And this created this big, complex data set, which students then had to interpret for themselves using some of these tools, both the theory and the data analysis, to produce a report. So rather than just being exam-based, there's an exam, there was a large report which students, it helps them not only learn how to write a large report, but prepares them for the report writing that is needed for their dissertations in the following year. And also transferable skills in terms of the programming. So it's both hard and soft transferable skills being delivered here, but also some theory as well, which was used in later on courses. So we're trying to integrate our courses as much as we can between years, so the stuff will actually be useful later on, but also to integrate more of these useful skills that employers kind of like. So one of I guess there are two ways that we are encouraged to change what we do, okay, in terms of the teaching delivery. I guess the one that we pay usually most attention to is actual student feedback. So at the end of each course we say, what did you like, what didn't you like, what did you learn most from, what did you think wasn't so useful. So we try and separate out what you like from what you learn from. And we take that on board, we modify courses a little bit. But we also make use of our alumni network. So we have a group, our professional advisory board, which are an organisation which is basically bringing together alumni across a range of fields. So oil extraction, through environmental consultancies, through kind of non-geological, so working in banks and whatnot. And they tell us what they want out of our graduates. And they constantly tell us they don't want our students to know any more stuff. Okay, so facts, figures, things like, which geological unit is above what in the Celsian in Westphalia or something. That great that you know that, but what they really want is students that can look at complex data sets, that can work in teams, have these transferable skills. So we're incorporating those kind of things more and more into our courses. Right, so looking into the final year, so the fourth year, so there's this large dissertation. So if you do geology, that'll largely be a field mapping dissertation where you go out into the field on your own and produce a geological map using some of the skills that we've provided for you in the previous years. For the other degrees, it'll be much more of either a lab-based. I mean, you can still do field work as part of your dissertation, depending on what degree program you're doing. You still have some field work. It can be laboratory-based entirely or in part. It can be computer modelling-based. It's kind of whatever interests you, you can end up doing. And you can make use of the wide range of staff we have for that. There'll be some core courses. They're listed here. The words vaguely describe what they do. But you have many options open to you as well. So this is an example of some of the options available to the geology and physical geography students. So there's a huge range that you can do in that fourth year, depending on what your interests are. So it could be on volcanology, it could be on marine systems and policy, geophysics, metamorphism, ores, anything that you kind of, I think that this doesn't really include most of the geography options, but there are more geography options as well available to you. So it's a huge range of things you can choose from. And if you want to check out the Path software, it should be available to you. You can flick through and look what it is available and what isn't. And when you're in the website, if you click on one of these boxes, it'll tell you more about that course. So the other thing that our teaching incorporates, being an earth sciences course, is being outside, okay, doing some of this stuff in the field. And we do make quite a lot of use of the university being based in Scotland, because Scotland is such a fantastic place to do earth sciences. So within the city of Edinburgh, we have our own volcano, which is fortunately extinct, but it does mean that we can kind of essentially, the erosion has allowed us to climb inside the volcano and look at some of the processes that were going on during eruption, before eruption, after eruption, and some of the sediments in that environment tell us about what was going on at that time. And we use this extensively for our teaching. But we also go around other parts of Scotland. So this is northwest Scotland up here, this beach here, which quite often gets used mistakenly for tourist marketing in the Caribbean, but is in northwest Scotland, I promise. We also go to, so this northwest Scotland up here. This is Mull, where we take one of our third year courses. This is down in the borders again. So these field trips happen kind of, once or twice a year. You go away on a residential trip to learn some specific thing, either field mapping or environmental sampling or stuff like that. But we also incorporate field trips into some of our other courses, which are not just field-based courses. So, for instance, our course in paleontology in the third year is mostly taught in the field. And we're able to do that because the university is located in Scotland in such a position that all of the good sites are reachable within a day's drive. So this is a map of Scotland, for those of you who are geographically challenged. But the colours on here are the different geological terrains. So these are basically different bits that have been stuck together as plate tectonics have gone apart and smashed together, apart and smashed together. And they represent very different geological environments. So you can see, be kind of the red bits are intrusive granites. But in the southern uplands down here, this is a bit where sediments were scraped off an oceanic plate, it's subducted underneath Scotland. So this is the kind of environment that is currently being formed in the area around Barbados in the Atlantic. Okay, so that's an accretionary prism. Midland Valley is a series of sedimentary basins. There's some volcanics in there as well. The Northwest Highlands, this is a place where we've got a fossil mountain belt. So it's kind of like the Alps, but on the inside. So we can really kind of tease apart the process of mountain building in these environments. We've got supervolcanoes in Mull and Rum. So it's, lots of cool stuff for us to do. We also go to not Scotland because some of the environments are not represented in Scotland, and it's also quite fun to go to some of these other places. So we go to places like Cyprus. In the fourth year, they're off tomorrow, in fact. So Gillian, who was in the lab earlier on, she's off to Cyprus to help the teaching there. Environmental geoscience has said go to Jamaica. This is the Lake District, which is in England. We've got Iceland in the fifth year. This is Cyprus again. There's also somewhere in Spain we go as well. So go all over. I mean, I think you've got a brochure in your packs of more details about each of the field trips. There's also a field trip blog, which is described in how to get to that in the pack as well, which tells what goes on. Fun things happen, as well as teaching. So it's not just fun things, it's not just teaching, it's I guess an appreciation of the historical context of the development of earth science as a subject as well, which is important. So Edinburgh is the place where geology was really developed as a science, and it's quite nice to be able to do the teaching of the basics, the fundamentals, in the places where it was first figured out. So this is an example where I think actually they're going tomorrow, the second years, are going to this place called Sicker Point. So if you have a geology textbook at home, or with you, I don't know why you bring a textbook with you, it will almost certainly have this figure in it, this picture. So this is a place called Sicker Point. It's quite often known as Hutton's Unconformity. And you can see that there are some vertically bedded rocks in this part of the figure, and then some more horizontally bedded rocks above it. So what James Hutton figured out here is that there must be some huge amount of geological time in between these rocks being laid down. He figured out those had to be laid down horizontally, and then they had to be tilted to be vertically and eroded to produce this. You can actually see the fossil landform. You can map that out, and we map that out, our students do that. And then you can see the sediments then being deposited on top of that. And then the key thing at this site is that he said there's this constant cycling of this happening. Because if you actually look at what's happened, this has been tilted again and then eroded to the current landform. And then if you go offshore, there are sediments being deposited. So this is one of the ideas, that there's this constant cycling of sediments being formed, mountain building, and erosion, and then a cycle repeating. And the idea at the time was that cycle repeating forever. Okay, that turned out to be wrong, but so the Earth does have a finite age. But this was one of the first places where people were figuring out that geological time was very, very long, and not the 6,000 years the Bible suggested at the time. So these are some of the guys that figured it out, and it's quite nice to say, oh, I went to kind of the university where Hutton and Lyell went. But that's kind of a little bit irrelevant in terms of the teaching that we do now, because obviously we don't teach the stuff that they taught because it's wrong. But the reason I show this slide, I mean, we also had founders of oceanography and radiometric dating up here as well, and Peter Higgs won the Nobel Prize, and isn't that fantastic? What's important is actually this guy in the middle here, this John Playfair. So not a scientist, just a really rich guy in the 17th century, 18th century, sorry. And he hung out with these guys here. He was kind of like a hanger-on to the scientific enlightenment. But these scientists, as scientists tend to do, they write really, really boring books, like really, really terrible books. Science in them, fantastic, but really hard to read. So actually, the science would have got absolutely nowhere. There would have been no public engagement if it wasn't for John Playfair, who basically popularized the science through a series of talks, lectures, seminars, and writings where he was able to write it in a more digestible way. And the reason I bring this up is because that's the kind of thing that we're incorporating more and more into our teaching. So we have, in the fourth year or the fifth year, depending on when you want to do it, a course in geoscience communication, okay, or geoscience outreach, I think it's called, where students come up with a project of their own, some particular aspect of geosciences that they're interested in, and they communicate that in some way of their choosing to the public. That could be a series of YouTube videos that they make, some lecture plans that they write for primary schools, outreach boards that you kind of quite often see dotted around. If you go to Skye, I mean, if you're not going to come to Edinburgh, don't bother going to Skye, but Skye is fantastic. It's brilliant. You should go there. It's awesome. That's a place to go on holiday, but also there's some really cool dinosaur stuff on there as well. So one of our academics, he's been discovering dinosaurs all over Skye, and we now have a bunch of little boards that are positioned around. There's like a dinosaur trail you can go around Skye. So that's kind of thing that you could end up doing for your project in that course. So the idea is that communication is a really important part of our teaching delivery now. But it's not just old dead white guys. We have lots of exciting scientists now in Edinburgh. So we have people like Gabby, who's one of the lead authors of the IPCC climate change report. We have Pete Nino, who's one of the world's leading polar scientists. So he's just recently won the polar medal off the Queen. Gave him, well done, you've done well doing polar science, you got a medal. Steve Brasati, one of the country's leading paleontologists, quite often on the BBC, kind of telling everybody about some fossils that he's found, or somebody else has found and he's commenting on them. People looking like Eliza, who's looking at volcanic hazard. We just hired Murray, who's a coral ecologist, looking at some of the coral reefs around Scotland and the UK. So Scotland has quite a lot of coral reefs, apparently. Deep water, cold water corals, but they are essential for the ecosystem services that they provide. So all of our fisheries would be pretty in a poorer state than they are, a pretty poor state at the moment, if it wasn't for the coral reefs that are surviving, basically hatcheries for fisheries and stuff like that. So he's involved in that. Huge range of people that are available to help you do what you want to do in your fourth and fifth year courses. So moving towards the end of your degree, you might be thinking about things like careers, what you want to do afterwards. So the university, every university has a very good career service department now. So we have a dedicated person within the career service that's just for geoscience students to help them get internships, get kind of jobs, work with their CV, improve it. Both also, before you come to write it, you also need to go speak to these people because they might help you decide what things you might want to do during your course, what would help you build your CV. So we have a number of things that students can do to help with that. But we don't just leave it to the careers service. The School of Geoscience is very proactive, engaging with our alumni community to bring people in from industry to give talks about what their career started out, how it progressed, what they need to do, students now need to do to go into that profession. So there's one of those talks every week during term time in semester 2, and students find that very helpful. So the kind of places our students end up, largely further research, either PhD or master's level. Just like with most kind of Russell Group universities, our students end up kind of staying in Russell Group universities. It used to be that geoscientists predominantly went into these kind of extractive industries, fossil fuels or mining. That still is the case. We do still send students to those industries. They are important. If you like being warm and having stuff, it's like having a mobile phone. It has lots of kind of important rare earth elements inside it, which you need to mine out of the ground. It's not a big growth industry there. Particularly for the renewable energy sector, they need a lot of high-tech resources. Those require being mined out of the ground. Neodymium for the magnets, for instance, for wind turbines, we need for mining. But more and more our students are going into industries which are making sure that these activities are being done in a responsible way. So it's not just digging out of the ground, making lots of money. We need to make sure that that's not ruining it for everyone else. Okay, so quite a lot of our graduates are going into water resources, into regulators, environmental consultancies. In fact, some of the companies that do the extraction, so BP, Texaco, all those kind of nasty companies, they still employ environmental scientists now to effectively do some of this activities in-house. Because if they're not doing that, they don't get investment because investors are like, well, you're going to get sued for loads of money in the future, so I'm not giving you any of my money. Things like nuclear waste, carbon capture and storage, becoming larger sectors which our graduates will go into. Carbon capture and storage hasn't really taken off at all in the UK because the government kind of pulled the plug on it, but it is being explored in other countries, and Edinburgh University is heavily engaged in that sector. And it's not just carbon capture and storage, it's just, I guess it's written down future energy, but things like using geological reservoirs to store energy, either in hydrogen or as in compressed gas, from our renewable energies like wind turbines and solar and that kind of stuff, so we can store it over longer than a day, which is kind of what we can currently do with batteries. But that being said, all of these careers that you could end up going into, you really are not limited to what a geoscientist can do. Okay, because you'll end up with a physical sciences degree, you'll have quantitative analytical skills, you'll be able to deal with complex data sets in a quantitative manner. You'll be able to work with incomplete data sets, which is a real skill, because when you make observations outside and of real rocks and things like that, the data are quite often imperfect. Okay, you don't always have all of the information. Just like the practical earlier, okay, if there were more examples of the different kinds of suites, it would have been easier to draw the family tree, but you don't have that information. And that's particularly important with things like the finance sector. You never have all of the information. You have to make informed decisions based on what you have. And geoscientists are really good at doing that. So just coming back to our staff, so while you're at university, you will have one of these people as your personal tutor. So it could be me, it could be Paul, it could be... There are lots of people, they have names, I could probably remember all of them. But that person is there to guide you through your time at university to make sure that you are making sensible choices when it comes to your options. You don't have to take that advice. If you really want to do something stupid, we will allow you to do that. So they're there to help you make good choices, but they're also there to kind of make sure that everything is going okay throughout your whole degree, to provide help and assistance, or to point you in the right direction for when that comes. We also have, so you might have met Emma earlier on today, our student services coordinator. So we have a wide range of kind of levels of support if things start to go a little bit wrong. So I just point that out. So these people are here to help you academically, but also will make sure that everything doesn't go horribly wrong. But yeah, so once again, I was just talking about it's the students. The students also help with this. So whether it be your resident advisor in the halls of accommodation to help you make sure nothing goes horribly wrong, but also in learning as well. So the students, again, are really important for helping learning. So this is a shot from the end of one of my lectures. It's not. But the students are here to help with lots of other ways. So the students, they organise field trips for fun. So that's part of the University Students' Union. We have the Geological Society, which is a kind of a society for the geoscience students. There's also a Geography Society and an Ecology Society. And they organise kind of for fun field trips, organise also for fun talks and seminars, but also for fun other activities, which I will not go into. But they also we have this peer-assisted learning thing where, as well as there being lectures and practicals and tutorials where someone like me is in charge, we have a thing which is actually just set up by students for students. It's where every 2 weeks, so I think Liz, who will be upstairs, runs this at the moment. So there's a session anyone can rock up to once a week, or once every 2 weeks, sorry, and students from the third and fourth years are there to help provide advice on what courses you might want to take, but also to, if you're not so hot with making measurements down one of those microscopes that we had, they'll run a session for how to make measurements running the microscopes. If you are struggling with some of the maths, they'll run a little bit of a maths workshop for you. So it's kind of, what they do is up to them. We have literally no control over it whatsoever, but that's what kind of makes it so useful, okay? Because it works kind of in contrast to the more formalised teaching. You'll have a big alumni network from all of these fancy pants students that we'll be graduating with a cap that gets sent to space. It's kind of, all of our students get graduated with a radioactive space bonnet. It's kind of a bit weird. But Edinburgh is, talk about space. We stay on the Earth with, our student population is really broad and diverse because we're a big internationally recognised university. We bring in lots of students from all over. We have an exchange programme as well, so students in the third year can go abroad, which means that students from other universities come here and study with our students. And that brings in another aspect to our education within that transferable skills aspect, in that you'll be forced to work with people who are hard to communicate with, and you'll be forced to improve your communication skills. So that's a big bonus. It also, gets you to meet lots of interesting people from all over the world, which is quite good fun. Right, so to summarise the first part of the talk, which was about the courses, so these are kind of the reasons why you might want to come here. So I guess I'm obliged to say we're this internationally recognised school, but that is not... That is just throw that on the floor. Let's do that again. Oh no, the batteries have come out. It's a disaster. So the fancy pants, really old university, founded in the 12th century or whatever it was, not important. What is important that you'll have a good time at Edinburgh doing the course that you want to do. Our courses are really flexible. You get to do a lot of options, particularly in the first 2 years, to really find out what it is that you want to be doing. And we're able to do that because we're this really big group of geoscience researchers. We have this huge range of expertise here. So it's there for you to use. So I'll stop there, and I'll peer out of the door to see if the accommodation person is here. No. Right. So I put the accommodation hat on. Put the accommodation hat on. I won't put the accommodation hat on. That's a stupid thing to do. Okay, that is the end of that presentation. And we'll now seamlessly switch into the presentation for accommodation. So I won't give the presentation for the Students' Union and the fun things that they do. They do lots of fun things because I'm not a student. But we'll make that presentation available to you. And if you have any questions about what societies you might be interested in doing or joining, or whether the students have been involved in the Students' Union, all that kind of stuff, you will all become members of the Students' Union by default. You can ask them upstairs and we'll make the presentation available to you. But I'll talk about accommodation. So we're going to go later on, we're going to pile onto a coach and go and have a look at some of these rooms and canteens and kitchens and all kinds of fun stuff that they have down there. But this is going to provide some facts and factoids about the accommodation. So I think the first and most important message to get across is that we, as a university, guarantee that you will get university accommodation in your first year if you want it. Okay? If, very small if, but big meaning. So first if is that you have to apply for it. So you've got your offer of an academic place at university, but the application and the kind of the granting of accommodation is separate to that academic application. So probably the most important message that you get from the whole day, other than come to Edinburgh, it's fantastic and awesome, is that you have to apply to the accommodation office by the 16th of August for accommodation. Okay? The sooner you apply, the higher up on the list you go. Another rule is that you have to live outside the city of Edinburgh to be guaranteed accommodation. So I think the current definition the university uses, which is ridiculous, is anywhere with an EH postcode, which is kind of a huge bit of Scotland. But that doesn't mean that you won't get accommodation. It's just that you'll be on a different list. So you might find out a lot later whether you have accommodation. I think most people that want it, that live in or around Edinburgh, do end up getting it. It's just that we can't guarantee it because of the numbers of students. And the last one doesn't really apply to you because all of our courses run for the whole academic year, so that's not relevant. But so the most important thing is apply, apply, apply. So the process is that you already have this offer to study. Congratulations, good job. Actually, I'll just stop here and switch back out of accommodation language and go into admissions language again. I'll switch the hats anyhow. So you will almost all have an offer that's around about either 3 A's at A-level or 3 or 4 A's at higher, something around that for if you have a conditional offer. If you have an unconditional offer, it's great, so you don't need to worry so much. Now, the rules or the policy that Edinburgh has are slightly different for Scottish and EU students versus RUK and overseas outside the UK students. And if you are an RUK, so England, Wales, Northern Ireland, or overseas student, and we've given you an offer of, say, 3 A's, and you don't get 3 A's, you get two A's and a B, something like that, then it's not over for you. So the university does go through the process of clearing. We just don't tell anyone about it. So usually you'll get, I think, the Telegraph or something like that, and there'll be a list of kind of all of the courses available through clearing. Edinburgh will not appear in that list. But if you go to the university's main webpage, the www.ed.ac.uk, that page for 1 day on clearing changes into the clearing webpage. And that will tell you the number to ring. And you ring that number and you say, I missed my offer by 1 grade or 2 grades, or I don't have the right subjects or something. And as long as you've still met our minimum entry requirements, which, depending on which degree, is kind of A, B, B, something like that, we will still consider you for a place. It's not that we'll guarantee to give it you, it's just that if we can, we will take you. Now, for Scottish and EU students, the university has not made a decision yet whether they're going to go through that clearing process for all students. They're definitely going to do it for RUK and overseas students. They may still decide to do it for Scottish and EU students. So even if you're Scottish or EU fee status, it's still worth checking that website if you do miss by a grade or so. Okay, so and you can ask me about this more upstairs if I've not made that clear. I quite often don't make things clear, which is why I record all my lectures, so people can play them back to me and say, "You idiot, you explained it wrong." Anyway, so let's assume that you've got this offer to study. You need to go to this website, myed.ed.ac.uk, which you might have already been to, but it requires a login, and you've got the password, which is your username, which is something that begins with S, and then lots of numbers, which you should all have. So you apply via that. Now, when you get unconditional status, that might, if somebody... Come in.
We're just waiting.
You're just waiting?
Yeah.
Okay.
Yeah, it's all cool.
Are people wanting to eat stuff upstairs?
I mean, the food is ready. We're waiting.
Okay, well, yeah, just leave some food for us. Yeah? Okay, cool. I obviously like my food, so yeah, we'll get through this. You get your unconditional status. That can either already have happened or when results come out. And at that point, the university will email you. Okay, this is another important piece of information. The email that they will email you at is the email that you have given us. Okay? Seems sensible, right? So if you suddenly decide to stop using that email, or go on holiday and don't check that email, or whatever, then you will not be able to respond to that email, right? You must respond to it, okay? So you have to accept the offer of accommodation. If you do not accept it within 7 days or a week or something like that, that offer of accommodation disappears. Okay? Not a disaster, you just go to the bottom of the list, okay? And you might not get what you asked for. So it's really important that you apply and that you have given us an email address which works and that you check. If you can't check it because you're going to do some expedition in kind of Saudi Arabia or somewhere remote where there might not be, or China where they might block your email, you need to give access to your email to somebody you trust. It might be someone sitting next to you, might not. So that person could respond on your behalf. Okay? So that's really important. Apply, check your email, reply to your email. Okay, so before you apply, it's worth thinking about what you want to apply for. And the two main options are you have some accommodation where you cook for yourself, self-catered, or someone cooks for you, catered. Jeff wants the food. Yeah. There are options of ensuite or shared bathrooms, modern or not modern, big rooms, small rooms. They all cost different amounts. So just to clue you in, we're down here, King's Buildings. Most of the student accommodation is around here, for the catered accommodation in Pollock Halls. Some of it is around the central area, some of it is down in the new town. Most of your lectures in the first year will be in central, in geography, and some will be up here as well. It's very easy to get between the two, either by walking or bike, or there's a free bus that shuttles down between the two. Very straightforward. These are some words. So depending on how you want your life to work out, if you want to do lots of sports, lots of societies, if you're going to be doing stuff at 6 o'clock at night, you'll miss dinner. So go for self-catered. If you're lazy and want someone to cook for you, catered. Very straightforward. The catered accommodation, well, we'll go down and have a look at this later on today. There's big ones, there's little ones, there's ensuite, there's not ensuite. Even though you'll get your cooking done for you, there are small kitchens, we'll see those. The food is surprisingly good. And these are the kind of things that the rooms look like. You'll see this room pop up quite a lot. I think they've just taken a photo of it many times. It's the neatest room in the university, perhaps. It's actually my shirt. Look at that. There we go. Anyway, I've not been in this room before. These are the kind of nice places you end up to hang out and whatnot. Catering facilities, they win awards, bronze awards, not gold, but still awards. The self-catered is more of a variety in terms of size of rooms and buildings. They're in a range of locations. You get to be more independent. They look like this. I mean, university accommodation always looks like this. Some of it's old, some of it's less old. There's one of those rooms again. So costs depend on exactly which room you apply for. So it's more expensive if you have catered accommodation and it's big and it's ensuite. If it's not ensuite, it'll be cheaper. If it's smaller, it's cheaper. We have twin rooms, which are much cheaper, but you have to share that room with another person. You do get a bed each, which is quite nice. You get self-catered is, again, a bit cheaper, but again, once again, there's a huge range. So how do you decide? You go to this website, www.com.ed.uc. There are some financial help for those that need it. I'll just twin rooms. So if you put us down as conditional insurance, you're still guaranteed accommodation, and it's still likely to be what you want, but it might end up being one of these shared rooms. It's cheaper. Actually, they're really popular. They're in quite high demand. But it's like going to university in an American movie, apparently, where you share with a chum. The rooms are bigger, and you get like another friend, whether you like it or not. Right, so this is the website that you need to go to check this kind of stuff out. The important thing is to go to this accommodation search thingy, and from that you can search all of the university's accommodation. There are pictures of all of the rooms, all of the common facilities, the common areas, where it is, how much it costs, and you can kind of search through that and make your decision based on facts, which is novel. So it's not just a room, so it comes with Residence Life, which is this kind of resident advisor system where students from the second, third and fourth years, they stay back to kind of help out, to make sure that you're having a good time, you're not having a bad time. They organise fun parties and whatnot, ceilidhs and human pyramids of sorts. So the Meadows is quite a nice area in the middle of town. You should go, and, if it's nice, you should go and see it. It's a very nice area. So they enforce fun for the first kind of term. So after the first year, that guarantee is kind of gone, but it's not like totally gone. You can still stay in university accommodation after your first year if you want to. It is reasonably well priced. There's a website which will tell you all about it. It's a lot easier, so you don't have to go through this process of searching for somewhere and arranging contracts and deposits and all that kind of stuff. So there are no guarantees or deposits required for this. But if you do decide to go out into the private sector, the Students' Union and the university have kind of separate sources of help to make sure that you're not getting kind of ripped off with crazy guarantees. Actually, it's one of the good things about living in Scotland. It's a lot harder to be ripped off by a landlord in Scotland than it is in England. In fact, it's impossible. It's illegal. There we go. We have laws. Great. So this is another thing that the students have set up for themselves. So this is a housing cooperative, which is hugely oversubscribed, where the students have basically taken on the lease of one of these privately run student accommodations, and they've fed up with paying too much rent, so they took it over. Legally, I mean, they didn't like squat. But, so this is another thing that's hopefully being expanded into the future as well. But yeah, check that thingies. So that obviously is for last year. So to recap, apply. Just apply for accommodation even though you've got a place already. Okay, very important. Yeah, so you apply online through the MyEd. Once you've got your unconditional offer, respond to it. Okay, you have to kind of sign the contract electronically and accept that offer of accommodation. Otherwise, it will go to someone else. Okay, so for more information on accommodation, go to the website. I mean, they have social media for all those people that do that. I think I'm supposed to do that as well. So that is a resource available to you. Okay, we're going to go down there later on today, so you can ask them directly. Also, if you have questions. Okay, right. I think that's us for today. So what we're going to do now is go upstairs. So if you head out of these doors, up the first flight of stairs, and then immediately turn left up a small little staircase, and that'll take you up to the museum where there will be food and people that are really annoyed that I've run over again. So go and talk to them. There'll be other lecturers there and students and sandwiches. Sorry, sir. No.